Yes. All right. So we're rearranging this formula, trying to get that W all alone. So that W equals all this other stuff. And that's in this thing. And my approach that I've tried to emphasize, look for the term that has the variable in it that you're after. So there's that piece. And any other terms that might be added or subtracted to it are good choices to move first or cancel out. So we want to get rid of the 2L. It's being added. So let's subtract it from both sides. It is being subtracted from what's already there, that P. Make sure you write it as P minus the 2L and not the other way around. Okay. If we do that, that still leaves the 2 W's. All right. How do I just get 1 W? Divide it by 2. Now to divide this side by 2, that works pretty easy like that. But the same thing really works over here. So there's, I'll write out a couple different ways you could show that or present that, right? Here's that whole left side divided by 2. Well, remember, dividing by 2 is the same as multiplying by 1/2. If you want to think of it that way, over on here, this is a quantity. We would have to say 1/2 times this entire quantity in parentheses like that. But that, totally equivalent, right? That's 2 is like it'd be on the bottom of the big fraction. So a couple different ways to present the final answer. All right, hope those steps worked for you. Now, my follow-up question here, this is sort of made up example, it is a made up example by me of how this, why this sort of technique might be worthwhile. If you wanted to figure out the width of a rectangular area, and you knew the perimeter, you knew the length, well, if you had your formula solved like this already, I can plug in the perimeter total and I can plug in the length, and all the work is set up for me there on the left side, right? So I'm just going to sort of do that over here. I'm going to substitute in those numbers and say, okay, the perimeter is the 500 minus twice the length. I'm going to put that in one parentheses, just kind of hold it together. And then whatever that is, we're going to divide by 2. All right, so that's kind of an order of operations problem now. Let's do that multiplication and then subtract. This is just kind of an extra thing I'm doing. Don't worry too much about it, I guess, but kind of showing how this all could work. And I think that turns into 220 over 2. Squeeze it in here. And so the width equals what? 110 feet. Remember, any problem like that, you want to make sure you include your units. That little dash works, or FT, something like that. So that's kind of the argument for rearranging a formula for the quantity that you're going to look for before you plug the numbers in. Yeah, it wouldn't be too difficult the other way around anyway, hopefully. You know, if I'd started this way, right, I just have to do all that rearranging and manipulating now, and the numbers are in there already, and maybe you like it that way better. That's okay. I would still, at this point now, say, oh, leave those W's, let's move the 280. And I get that 220 is 2W, and so I divide by 2 and still get the 110. Okay. Anyway, at least the first, probably 2/3, first half of sections 3.4 is, like I say, geometry problems basically going to be based off formulas like this. And then they'll give you some numbers to plug in, but not everything on one side, right? You know, it's just like this one. It was one of the pieces over on the side there that I was going to have to rearrange and find. So 3.4 is problems like that, and it'll include circles and maybe triangle formulas, things like that. Okay, just a start. That was a warm-up. How about one more warm-up? Let's do this here. Pick your favorite way to do this. Not at all. No, I mean. These have been so much fun for us. Let's try one of those again. Okay? I'm gonna wait. I'm gonna wait for you. First technique was kind of multiply to get rid of the fractions, make everything bigger. Second technique I presented one day, I guess, just work with the fractions, move things around and combine fractions eventually. I just made this up this morning, have no idea what the answer will be. Hopefully not too crazy. My designer coffee cup, my granddaughter's made these, got a couple of those for me. Yeah, whatever is it, Hot Tots or something? You go paint your own pictures, paint your own stuff. Ugh. Yes, I know we're going to deal with percents today. I hope it's not too distracting, or whatever term you might use, that we're reviewing other things first. I hope that doesn't mix you up, get you off track. I'm going to use that, combine the fractions, second technique myself. I'm just going to do a couple steps here. What did I do? I added the 1/2. I got all the x's on the left side and all the constants on the right side. Do what you, whoop, gotta let a couple in here. Get them in here. There we go. Combining fractions. I tried to make them not too crazy, not too complicated a denominator, not too many different factors to worry about. Hopefully it's kind of clear that here, if I was dealing with just the fractions, I'd get 6. And here I would just get fourths. Stop shaking so much. I've got size 6 pieces, so I can combine them. They're all 6ths of x. 4 minus 5 means I have -1 left. -3 plus 2 means I have -1 of these left. Now I want to get it down to 1 positive x. Multiply by that reciprocal. So just to do that, I'm going to put some parentheses, make it look like that. And same number on the other side. Don't do 4 over here. I was thinking of that as I go on. Whatever I decide to multiply by, it's got to be the same thing on both sides, right? And negative, negative. It's going to cancel, become positive. Got rid of the 6's, so there gets our plain x. Negative, negative again. 4 here and 6 here. I could get 6 over 4, or maybe notice I could divide by 2 right now and get 3/2. Did you get there? I hope you got there. I see some yeses. I see some blank faces. It's okay. Hopefully you're getting more comfortable with that. Hello, kitty. All right. On to our main event then. All right. Check entry. Should we review the basic percent problems from yesterday? Yes or no, somebody? Or yes, if you really want it. Otherwise, I'll go on. Yes, please. Or, okay. Nobody's chiming in. Let's do our next step. Percent increase or percent decrease? Sometimes also just called the percent change. You know, which way are we going, up or down? And, oh, just a general context, let's say a fee increased, CR, increased from $26 to $36. What was the percent increase? All right. This category, percent increase or decrease, basically involves two steps. Whether you, and you know, you could do it this way or you could do it this way. It's eventually get the same spot, you know. There's more than one way to do it. You could do your one step beginning or at the end kind of thing. So the way I like to present that, first we find the amount of change. All right, first step is find the amount of change. That's a subtraction, it's just a difference. All right, take the big number minus the small number. The amount of change was $10. That's the number I'm going to use now. All right, it's this 10. And then compare the change always with the original. With the original value. All right, we're always comparing that amount of change to what it changed from. Right, the original value, it increased from 26 up to 36. So we're asked, what percent of 26 is 10? You know, what part of that original value, what percent of that original value did it change by? So there's actually my sentence, right? What percent of 26 is 10? Now, look, that's supposed to look like a 6. Didn't come through on the board very well. All right. That's a yesterday problem now, right? So there's the two steps. The first step was, figure out the amount of change that we're going to work with or compare. So we really don't care about the 36 specifically, other than it created a $10 change. So compare the 10 to the 26. And so here I'm saying, what percent of 26 is 10? All right, what percent of 26 is 10? And so if I divide by 26, I get 10 divided by 26 on both sides. I'm sorry, on the right side, right? Divide by 26 on both sides. And problems like this should tell you how many decimal places for your percent value, because it may frequently not work out even nicely, whatever. So I'm going to do round my percent to 1 decimal, to 10th place. And so 10 divided by 26 and 0.3846. Okay. Ellipsis. Really only need 3 dots. Mathematicians use those. 3 dots means kind of goes on forever. Right? Now, there's my decimal value. Remember, percent, you have to change to percent, not leave it as a decimal. So I'm going to move it over to right? And if I was going to round my percentage to the nearest tenth of a percent, that's the first decimal placed, right? Nearest tenth. You want that in your notes. Nearest tenth. So I'm rounding to the first place. You always rounding whole numbers or anything. You always look one more to the right and determine whether that means you're closer to going up or down. I'm going to go up to the 5. Here's my approximately equal to 38.5%. So 10, a little more than a third, right? 10 is 38%, 38.5% of the original 26. We went up that much. Find the amount of change and then compare it to the original value. Basic process here. Can I erase or shall I wait for you? I'm okay? All right, thank you, Glenn. And whoops, don't get ahead of myself. All right. IRS mileage allowance changes from, my notes here, what I got? 55.5 cents per mile to, that's supposed to look like a cent sign, 51 cents per mile. What was the percent decrease? Exact same process. This one just happened to go down instead of up. Amount of change. We're not dealing positive, negative. The problem told us it was a decrease. How much did it go by? Absolute value kind of thing. How much did it decrease by? What's the amount of change? So what I'm getting at, it's a big number minus a little number, right? What is that, 4.5 per mile. 4.5 cents per mile. There's my good units there. So it went down 4.5 cents per mile. Now, same process, compare to the original or starting value. Fine looking, oh there. Compare to original. 4.5 compared to the 55.5. Can you write your sentence? What percent of the original 55.5 is 4.5? Can't see that very well. It's all right. All right. Oh, by the way, I have to say, you know, whoever it was that was having trouble with entering in mom and the multiplication dot, I went back yesterday and tried a couple myself, and all the way up to the very end, of course, it's saying syntax error, and I put in the multiplication dot, and as soon as I left the box, it removed it anyway and wrote it the way you would like to write it. And I typed it without the multiplication. I'm sorry, it worked for me. I don't know what was going on.
Yeah, I thought about that, and I was like, maybe it was just me.
Oh, yeah.
No, it didn't work for me.
Oh, it didn't? I was like, I think
Yesterday.
that's just me, and I'm kind of embarrassed I said that in front of everybody.
No,
Oh,
it didn't work for me
don't be
either.
embarrassed. Gosh, if we were embarrassed, we'd never get anywhere. Here we go. What percent of 55.5 is the 4.5? Okay. trying to get the P alone, divide both sides by 55.5. Let's do, I'm going to stop and ask you to finish and round your percent to 1 decimal place. The nearest tenth of a percent. You round it correctly is what I'm saying. 4.5 divided by 55.5. This will probably work out even and mess me up. Come up with your decimal, round it, turn it to percent, and round it correctly. So those. Oh, that's one of those weird patterns. I got a repeating decimal. So hopefully you're okay with putting that in your calculator, but 081, 081, 081. That pattern repeats over and over and over, right? So that's the decimal. You have to turn it into the percent and then round to 1 decimal place, round the percent to 1 decimal place. That's totally arbitrary. Different problems may ask you to round to a whole percent or round to 2 decimal places or something like that. Hopefully you get good instructions for how to round. And so 2 places, and I get 8, let's see, 8.1, right? 8.1, 8.10. And so that's going to stop right there, right? The 0 is going to mean go down to 8.1. Hopefully that rounding works for everybody. Hey, kitty. She wants out. It's nice and sunny. You coming? Yeah. It's so true, all those cat jokes, you know. You don't own your cat, they own you. All right. That work? Or problem for anybody? Question? All right. There we go. And let's see. Population of North Dakota in 2010 was approximately, there's that squiggle thing, approximately 672,000. Changed to 630,000 in 2020. Find the percent change. Same question, same problem. Now this one, if I really framed it as find the percent change, it might be good for you to include in your answer that the change was a decrease of whatever number you come up with. If I had just said find the percent decrease, well, we know it's a decrease. So you could just say, oh, it was 20%. But we don't know whether it goes up or down. That would be a good qualifier for you to include in your answer, or maybe, you know, minus 20% or decrease 20%, whatever you come up with. Same kind of problem though. Find the amount of change and compare it to the starting value. I'm going to wait and let you do this one, okay? Luckily, we're using calculators with all these big numbers, lots of zeros. Who's got a number? What percent did it decrease by? I think it was But 42,000, was that the amount of change? There's my sentence, huh? Hopefully you agree, you've gotten that far. From that I can write my equation. Whoops, yeah. And you're going to divide, get the P alone, right? Oh, how about give me one decimal place on your percent? Who's got a number for me? Oh, you're still going, all right.
I have 0.0625.
Oh, I'm making a mess here. Now, is that your decimal answer?
That's my decimal answer. But my actual percentage answer would be 6.2% or 6.25. I'm not quite sure how far out I should go.
Okay. Now this one, were there more decimal places? If there weren't, you could say exactly
Yeah.
6.25. But if it kept going, what would you round that to for 1/10 of a percent? One decimal place, what would you say it was? Is it 6.2, 6.3?
Yeah, I would say 6.3. Well, no, it's in the middle, so I don't know.
That's the one you gotta know. 5 and up goes up.
5 and up goes up. So, okay, then it would be 6.3.
Yes. You know, the 0 is part of the low side. So you got 0, 1, 2, 3, 4 is 5 values. And 5, 6, 7, 8, 9 is 5.
So when we're left with 6.25, the expectation is to round it up to 6.3 to make it a whole.
If it's a 5, it goes up. If it's a 5, it goes up. All right.
Okay, I'm gonna write that down.
And if, again, problems should tell you where to round to. You know, hopefully you, like I say, you should get good instructions. You can complain to me if you don't. I'll give you credit if you don't. Something like that. All right. And I didn't do the math myself. Everybody else agree, right? Did you get that value, hopefully? I didn't do that. So let us know if you came up with something different for some reason. All right, so sounds like that must be good. All right. Find the amount of change and then compare that to the original to find that percent change. All right. Oh, and here's where I was going to say, yes, maybe we would say 6.3% decrease because it didn't tell us up or down. We should identify up or down. Let's write that in, okay? Or minus 6.3. I'd say for that example, you should include the qualifier up or down somehow. All right. All right, so I'm going to call this original price. Sort of related, two-step thing here. A shirt is on sale for 20% off, and sale price is $28. What was the original price? The pre-sale price. Original price. How good a deal did you get? Well, you got 20% off. That's not a bad deal. You know, that's why we can use percents. 20% here is this amount, 20% over there is a different amount, but 20% is still a good, same percentage, right? All right, so I'm paying 28, and that was 28% off of the original. So here's my two-step process for this kind. First, what percent did you pay? 28, okay, that's after the 20% off. If it's 20% off, what percentage is the 28? Right? Start at 100% and it's on sale, so I subtracted 20%. So I'm only paying 80%. So you got to kind of turn the percent around. All right, 28, here's my sentence, all right, is, what is it? 80% of what? Now, if I went too fast and you're writing, think about it. So it's on sale, 20% off, and here's what I have to pay is 28. What does it mark down from? Usually the stores, they tell you that these days, but you know, if it's 20% off, that means I'm paying 80% of the original price. So that's what I want to know. 28 is 80% of what original price? I'm paying 80%. So there's my sentence, gets me this equation. 0.80 if you want the 0. X, whatever you want to call your variable. Oh, you know, does it make sense if I'm dividing by a decimal less than 1? I'm dividing by something smaller than 1. I can always get a bigger number, right? So. And X equals, what do I get here? 28 divided by, you could just say 0.8, you don't really need that 0. 35. Nice round example number, $35. Don't forget units on any application or word problem. Think about the units. And maybe a final sentence, you know, the original price was $35. So this process, if we're looking for, if we know the percent change, we're looking for the original price. Right? So it's kind of flipped from the last couple of examples. So figure out how much, what percentage you are actually paying. There's your first step, and then compare it. So let's do another one of those, okay? And auto markdown, 20W, 15% to, find my good number here, 35,700. What was the original price? Can you set that one up? Can you do that? All right, and then I like this idea. Just write your sentence. Can you put it all in the same one phrase? Does that make sense? There's this combined sentence there. Getting low on the board. My penmanship gets worse than usual. So that sale price is 85% of the list price. Right? Make sure you change your percent to decimal. No, that's kind of a good check at the end. I got this crazy, huge, weird number. Doesn't make sense. Oh, I forgot to change my percent to decimal. You know, you can think like that. Something doesn't make sense. Go back and look for something you didn't do right. All right, I'm going to divide by the 0.85. And what was that car?
I got 42,000.
I'll take it, okay? Is that good, everybody? How about a confirmation? Everybody else
Can we do another one just like this? I found this to be a little bit more challenging as to figure out how to start the equation, but not how to finish it.
How to start up here, but not how to fit. No.
Yeah, like when I look at that, I did not know how to start that problem until you started working it out and explaining how to turn, the 15 into a different percentage whole. I mean, if you have another example for a question like that, I feel like that would be really handy.
Okay, if you allow me, I'm going to go the other direction. Instead of mark down, I'm going to mark up, but it's the same process. Let's see if
Okay, let's try it.
Okay, so it's the same idea. After adding 18% tip, let's say you pay $76.70. What was the original bill? Right? You added your 18%, $76.70. Gotta get my decimal points in there. Similar ideas here. What percent are you paying? This time I'm going up. I didn't discount. It's not 100 minus the difference. This time I went up. It's 100 plus. Right? I paid the whole bill plus 18%. I'm paying 118%. 76.70 is 118% of original, the bill, original. Now, does this, hopefully that makes sense that this is the same kind of situation as the last two examples, except that we're going up instead of down. The process I'm using is the same here. So I figured out, well, if I'm paying extra 18, I'm actually paying 118%. So this number is 118% of the original, which we expect to be, this is more than one, so we expect a smaller number, right? So 76.70 is, how do I write that as a decimal? Two places, right? 1.18x. There's my 18%, right? That's the decimal part. Now I'm dividing by something bigger than one, so that's how I get something smaller over here. Right? What is it, $60, probably something like that here. Did I really make nice round numbers for all these examples?
It's 65, but that's really close.
Yeah, I got 65. Good.
So quick question before we get too off track or move along to another problem. When looking at a percentage like that 118%, I had a really hard time figuring out how to turn that into a decimal. So simply we're just going to put the decimal point after the first number, just like we would have done in the last problem where it was 85%. It went before the 85. Like, what's a good way to remember where to put the decimal point in these problems?
See if you can back up and remember percentage is always a way to describe dividing by parts of 100. Here it is, I rose a fraction. I can always type that like that.
Got it. Because if I'm writing a decimal, the 8 is in the hundredths place. So that's why the decimal goes before the first one, correct?
Oh, yes, right, correct. So if I have,
Okay.
if I have 85%, right?
Yes.
That's 85 over 100. 85 to 100th. The 5 is in the hundredths place.
Yes, yes, because technically 85 doesn't have a third digit. Not putting it in the hundredths place, it makes it almost like a 10-digit number. So that's why the point goes before. That's okay. I can remember that.
Okay, I hope it's clear. I felt like I started going in circles there. I hope you're all right. All right, I'm gonna do another one of those. All right. I always like to save a couple minutes to talk about a couple weird ones in the homework here, but yeah, so we'll get there. And let's see. How about, luckily here, no sales tax, but here we go. The after tax price, and either, let's put the tax in. What do I have here? What was the, let's call it pre-tax price? All right, something you purchased was taxable, 12% tax on that item, and so that caused the final price to be $28. What was that price before you added the tax? Here again, what percent are you paying? Again, you're going up. This time it's 100 plus again. If it's on sale, you're subtracting, right? 100 plus 12 means you're paying 112%. I should have let you do more of this. Can you write your sentence? Finish it up. $28 is that percent of what we're looking for. Right? There, I'm just going to put the X in, okay? One, two. At 25. Did you get 25? You're not there yet, sorry. I got 25. Okay, hopefully that worked for you. We'll warm up with some more of these tomorrow, okay? I want to, like I mentioned, I always like to point out some oddities, you might say, weirdness in a couple of the homework problems that are in this section, all right? So if that was okay, I'm going to erase. Here we go. I end up almost kind of helping you work this through right here when I do this. We're talking about, what is this, 3.2% problems. First of all, number 6. I know some of you are all done with these. Good for you. But number 6, just like to see if I can describe it if you've not read it yet. A college student pays, my versions, right? Your numbers might be different. Mine says $650 for tuition, and $225 for books. We're very nice in the math department. We went to these free online things. The average textbook is $150 or something. That's amazing. Anyway, lucky you. The problem says, what percent of total education costs were books? This is a little different than anything specifically that we've done. What percent of our total costs was this book amount? Well, this problem doesn't present you the total cost. You have to add those two together to find the total. Usually I've been, for most of these problems, we compare to the original, Well, this is a variation where we don't know the total to compare it to. So I got to add all these together. So 225 is what percent of 875 was the new total. I had to come up with a new total to work this problem. So when you do your number here, yeah, right, copy this down. So when you go home and do your number 6, I help you remember it's weird. Okay. If that's okay, I've got one more and that'll wrap us up today. All right, here it goes. Number 9 is really unusual. If you really think about it, I know some of you did it already. That's great. So it says, your check, weekly check, is 10% less than your coworker. Together, add them together, is 745. I'm abbreviating. Find each paycheck. There's various ways to write this or think it through, but let's start. We're comparing everything to what your coworker made. So there's our first unknown. If we let X be your coworker's paycheck, what percent of your coworker's paycheck did you earn? This is kind of like this last section, right? Percent decrease. If you made 10% less than your coworker, you made 90% of X. Does that concept make sense right there? You made 90% of your coworkers. If you made 10% less, you made 90% of whatever that is. So I can write that now as 90% X or 0.9X. X minus 100% X minus 10% X is 90% X. Now it says together. So if I add mine in there, here's my coworker. If I add mine, that's supposed to add up to that total. Well, that's really weird. It doesn't exactly apply directly to our examples so far. It's just kind of mixing everything together. Maybe you can reason it out. You've gotten there, but it tends to be complicated, cumbersome for lots of folks. So here I have like 1, right? Got to add these together, right? 1 plus 0.9. I've got 1.9x equals that. And then if I divide, I'm going to figure out what x is. Remember, x is your coworker. And if the problem wants to know what you made, you've got to do the 0.9 yourself. 0.9 times that to find both prices. Copy that down, see if that helps when you get around to doing number 9 in your mom homework. we'll come back and warm up with a little of this tomorrow, and but then we'll jump
Well,
into this.
real quick, where do we go from here? Would we be making that 1.90x?
I just waved my hands, you should know. Yeah, add those together. Exactly, 1.90x.
I'm like, wait, no.
I wasn't going to finish. I did say that already. I know you were busy thinking. It's hard to think and write and then hear at the same time. I totally understand.
I guess I just had hopes and dreams you would finish the equation.
What was that?
I just had hopes and dreams you would finish the equation for me.
Yeah. Now, your numbers, I suspect, might be slightly different overall. But yeah, now I just want to divide. That will tell me what the coworker is X. And then to find my own, I still have to do 0.9 of whatever I come up with. Find mine. You can finish that now, I hope.
Yeah, perfect. Thank you.
Okay. All right, folks, it's a good day. And gee, I know you're probably working or something, but enjoy the sun if you can. And we'll pick it up tomorrow. Okay?
Thanks, Professor.
You're welcome. See you guys. See you, ladies and gentlemen.
Have a great day.
Thank you. You too.
Sure.